Right, this is the last lesson for Chapter 8. Chapter 8, Section 4, Proportional Theorems. We're still dealing with proportional sides, segments, okay? Triangle proportionality theorem, determining if it is proportional or figuring out what's proportional using parallel sides. Before I start this, it is super important that you guys stay consistent. When you're setting up your proportions, I'm going to write that at the top. That's something that you have to know or remember to stay consistent when setting up proportions. Okay, it's super important that you stay consistent because I'm going to show you guys a couple ways you can write it. Choose one and stick to it. Okay, and again, you can use these on other lessons that we covered. So, if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So it'll either tell you it's parallel or it'll show you it's parallel using the little arrows that we know are our parallel symbols. So here are my arrows. This is a way that you can tell if something is parallel. Keep in mind that does not mean they're congruent. If I have parallel lines cut by a transversal, I have corresponding angles, which mean yes, corresponding angles are congruent. So when I'm looking at this, we're setting something up proportionally. Okay. They're giving you AB over BC. Keep in mind it's not the added entire segment. It's just separate. AB over BC and AE over ED. That's one way you could think about it. Okay, the sides are together. The sides are together. Or you could also write it as AE over AB equals ED over BC. So think about it as I have left top, left bottom. Then I have right top and right bottom. So how they wrote it was you have your rights together, you have your lefts together. Okay, so right top over right bottom, left top over left bottom, or if you wanted, you could have switched it and done your left first and then your right. It's the same thing. But for the one that I wrote at the bottom, I did all my tops. Okay, so all of these values here are my top values. And then ED and BC are my bottoms. Okay, so you have to make sure you're setting it up. Choose one way and stick to it. That's all I have to say so you're not getting confused. Pick one and done. All right, converse of triangle proportionality theorem. Converse, if we forgot what converse is, all you are doing for converse is switching your if-then. So converse means switch if-then. You're just switching your if-then statements. So if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So like before, if they're giving you two sides that are proportional, so again, if AB over BC is parallel to AE over ED, or again, we could switch this, okay, putting the tops together and the bottoms together, then EB is parallel to DC, okay? It's just giving you the opposite, the switched rule. Looking at example number 1, okay, using what they gave me, CD over DA is proportional to what? How would I write that second one? Who could tell me? Yeah. Good. CE over EB. Perfect. I'm going to do these two in separate colors just so we're not getting them mixed up. So I'm going to do B in this pink and C in blue. So looking at it, they're telling me CD is 3, DA is 6, DE is 3.5. Find AB. So when I'm looking at this one, I can't just set up sides as proportional to sides because I'm not talking about my sides. I'm talking about one side, and let's call that the base of the triangle. So in order for me to do this, yes, you could think about it as two separate triangles. I'm going to have my top triangle, or let me just draw it out so you can see it. I have 3 and 3.5. And then I have my larger triangle, which is x, and this is going to be 9. I have to solve it this way. So looking at it, I'm going to do 3 over 9 equals 3.5 over x. Again, you could switch it if you want and put 9 over 3 equals x over 3.5. It'll still work. I'm going to do what we've been doing, cross multiply. I'm going to get 3x equals 31.5 divided by 3, and that x is going to give me 10.5. So AB is 10.5. All right, looking at C. For CB, I have 12. Oh. EB, I have 8. CD, I have 6, and they want me to find DA. So looking at this one, I can set it up for solving for x. Can anybody tell me what would EC be? Does anybody know? Yeah. It would be 4. Okay, I could set it up as my top 8 over x equals 4 over 6. Cross multiply. And divide. I'm going to get 12. That's one way you can do it. Or you can add the sides like we did before. So 8 over 12, will that simplify? I could simplify 8 over 12 to 2 over 3. I'm going to take my, let's call it, that is considered, let's say, scale factor equals x over x plus 6, because I'm adding the entire thing. So this is what we've been doing in the previous lessons. Cross multiply, I'm going to get 3x equals 2 times x plus 6, distribute, 3x equals 2x plus 12, subtract 2x from both sides, and I'm still going to get x equals 12, so that's another way to solve it, if you're used to adding the sides. All right, questions on B or C? Yeah. There's quite a few ways you can do this.
When I was trying to figure out before, I did like 4 over 12.
That still works. Yeah, you did what? 4 over 12 equals what?
Oh, I did it. Oh, I see what I did now. Instead of, I just got 6 by mistake. I said that I did 4 over 12, but you said I did 6 over 12.
No. You can do 6 over 6x or 6 plus x. You would have to simplify it and then you could still solve it. So let's see, you could do 1 over 4 equals 6 and 6 plus x. See if you cross multiply. you're going to get 24 equals 6 plus x, subtract 6. No, I guess you can't do it this way. Or did I do something wrong? No, this should be 3, not 4. Nobody changed it. This should be 3. You're going to get 18. Yeah, you could do that. It just matters how you set it up. It just matters how you set it up. So there's a lot of different ways you can solve this. Okay, that's why I told you guys stick to one way and stay consistent. All right, 3 parallel lines theorem. If 3 lines intersect 2 transversals, then they divide the transversals proportionally. So when you're given something like this, I think it's easier to do top over bottom, and where's my top and my bottom? I would consider these my top values, these my bottom values. So when I'm looking at it, these are my tops. These are my bottoms. Keep in mind, stick to one way. So you're staying consistent every time. They are proportional. All right, looking at example number 2. Looking at example number 2. Again, I'm going to do them in separate colors. I will do this one in blue, and I'll do this one in this purple pink color. All right, A is 2. B is 3. C is 5, and I want to find D. I'm going to do top over bottom. So my top values is 2 and 5 equals 3 over x. I'll go back, give me a second. Cross multiply, I'm going to get 2x equals 15. Divide by 2. X is going to give me 7.5. Okay, there are other ways to solve it, but again, stick to one. If you solve it a different way, maybe you did 2 over 3 equals 5 over x. Stick to that way and continue working it that way so you're not getting confused. So looking at the next one, A, they're telling me it's 4. B is 8. C is 5, and they want me to solve for the entire line of C plus D. So a couple ways you can do this. I can go ahead and solve for D first and then add, because C we know is 5, so let's go ahead and do it that way. I'm going to add 4 over 5, I'm going to get D to add, equals 8 over D. Solving it this way, I'm going to cross multiply. I'm going to get 4D equals 60, divide by 4. Did I do something wrong? Yeah, it's not 60. It's 40. This is 10. This is 15. It's a Monday. All right, so I could do it that way. I can solve for D. Okay, I'm solving for D, or I could just solve for the entire side. However, because I'm solving for this entire side, we'll call it X. I need to also add this entire side, which is 12. So how am I solving it this way? I will put it as 4 over 12 equals 5 over X, because again, 12 is the entire side, and X is the entire side of my right side. So cross multiply, now I'm going to get 60. 4x equals 60, divide by 4. X is going to give me 15. So I could just solve automatically for 15 instead of skipping that whole adding side. but it's really not that much work. You're just adding. We should know how to add. All right, triangle angle bisector theorem. If a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the length of the other two sides. So again, a couple ways you can write this. Here's the first way that's given to you. I have AD over DB, so I guess we can call those the corresponding sides, equals CA over CB. That's one way to write it. Another way you could write it is AD over CA or AC equals DB over BC. Okay, keep in mind if you're looking at these, if I cross multiplied, you can see that you're cross multiplying the same values. So let me highlight it. These two are cross multiplying together. And then these two are cross multiplying together. It's the same values regardless of how it's written. Okay, so either you could do the corresponding sides, which we're kind of used to, or you can do sides and sides together. All right, last slide, it says find x. Again, personal preference. Go ahead and write it how you think it should be written or how you want to write it. Okay, checking to see if we wrote it correctly. I'm going to have 10 over 12. You could write it this way. Equals, I'm going to solve for that y right there. Y over 24. Before I cross multiply, let me actually simplify. Simplifying 10 over 12 is going to give me what? Good, 5 over 6. I heard someone say it. Now it's going to give me smaller numbers. I'm going to get 6y equals 120. Divide both sides by 6. Y is going to equal 20. So if I add it, I'm going to get 30. You could do it that way. Or you could have done 10 over y equals 12 over 24. You could again simplify. Cross multiply. Y is still going to equal 20. Okay, questions on this?